Running IEX starts an instance of Beam, and then an interactive Elixir shell inside it. Runtime information is printed, such as the Erlong and Elixir version numbers, and then the prompt is provided, so you can enter Elixir expressions. After you type an expression, it's interpreted and executed. Its return value is then printed to the screen. Note: everything in Elixir is an expression that has a return value. This includes not only function calls but also constructs like if and case. Tip: you'll use IEX extensively throughout the book, especially in the initial chapters. The expression result often won't be particularly relevant, and it will be omitted to reduce noise. Regardless, keep in mind that each expression returns a result, and when you enter an expression in the shell, its result will be presented. You can type practically anything that constitutes valid Elixir code, including relatively complicated multi-line expressions.
JK, what the fuck? SB toggle secret. Oh, cool. Insert. How do I run? Comment, delete. Question, execute. Control, Control enter, evaluate cell, either mode. Previous. Okay. Oops. 2 times 3 plus 1. Divided by 4. Yeah. Sick, okay.
Notice how the shell doesn't evaluate the expression until you finish it on the last line. In Elixir, you need no special characters, such as semicolons, to indicate the end of an expression. Instead, a line break indicates the end of an expression if the expression is complete. Otherwise, the parser waits for additional input until the expression becomes complete. If you get stuck, e.g., if you miss a closing parenthesis, you can abort the entire expression with #IEX:break written on a separate line.
Break.
See this code.
The quickest way to leave the shell is to press Ctrl-C twice. Doing so brutally kills the OS process and all background jobs that are executing. Because the shell is mostly used for experimenting and shouldn't be used to run real production systems, it's usually fine to terminate it this way. But if you want a more polite way of stopping the system, you can invoke system.stop. Note: there are several ways to start Elixir and the Erlong runtime, as well as to run your Elixir programs. You'll learn a bit about all of them by the end of this chapter. In the first part of this book, you'll mostly work with the IEX shell because it's a simple and efficient way of experimenting with the language. You can do many things with the shell, but most often, you'll use it to enter expressions and inspect their results. You can research for yourself what else can be done in the shell. Basic help can be obtained with the H command.
Oh, in. Gotcha. In. Nice.
Entering this in the shell will output an entire screen of IEX-related instructions. You can also look for the documentation of the IEX module, which is responsible for the shell's workings.
See this code.
You can find the same help in the online documentation at this link. Now that you have a basic tool with which to experiment, you are ready to research the features of the language. You'll start with variables. Section 2.2, Working with Variables. Elixir is a dynamic programming language, which means you don't explicitly declare a variable or its type. Instead, the variable type is determined by whatever data it contains at the moment. In Elixir terms, assignment is called binding.
Oh, this ain't gonna work. There we go.
Elixir is a dynamic programming language, which means you don't explicitly declare a variable or its type. Instead, the variable type is determined by whatever data it contains at the moment. In Elixir terms, assignment is called binding. When you initialize a variable with a value, the variable is bound to that value.
Okay.
See this code.
Each expression in Elixir has a result. In the case of the equals operator, the result is whatever is on the right side of the operator. After the expression is evaluated, the shell prints this result to the screen. Now you can reference the variable.
See this code.
See this code. See this code. Shut the fuck up.
The variable can, of course, be used in complex expressions.
See this code.
In Elixir, a variable name always starts with a lowercase alphabetic character or an underscore. After that, any combination of alphanumeric characters and underscores is allowed. The prevalent convention is to use only lowercase.
I'm not sure why I paid for this fucking audio. It's like, I thought it was narrated by a person. This shit sucks. Alright. Even if I get it to stop, it still says, see this code. Fucking annoying as fuck. Alright, forget it. Okay, in Elixir, a variable name always starts with a lowercase alphabetic character. That's one of them rules. Okay, so Elixir, a variable is always lowercase. Or an underscore. After that, any combination of alphanumeric characters and underscores is allowed. Wait, any combo of alphanumeric and underscores is allowed. Okay. The prevalent convention is to use only lowercase ASCII letters, digits, and underscores. Or an underscore, okay. So I can do this. Equal fart. How about that, brother? Ha. Okay, valid build, valid but not recommended. Yeah, it looks like JavaScript. Okay. Variable names can also end with a question mark or exclamation. Also okay. Really? Fart. Okay, they're not lying. Snap. Variables can be rebound. Get the rebound to a different value. Nice and flexible. Okay. Okay, that's so me equal he, me equal 3. All right. How do I make a new M? Nice. Oh, I can't do that. 1 and 2. Please use. Why though? Can it do tables? Call. Or wait, is it? Yeah, it's call. Three. And then some stupid. Oh, nice, dude. Sweet. Oh, ass bitch. Awesome. Yeah, I really like this tool. Sick, brother. All right. Cool. Rebinding doesn't mutate the existing memory location. It reserves new memory and reassigns the symbolic name to the new location. It doesn't mutate the existing memory. It doesn't mutate. Oh, because it's functional language. Immutable. Right. All that stuff. I did hear that earlier today. You should always keep in mind that data is immutable once the memory location occupied with data. It can't be modified until it's released, but variables can be rebound, which makes them point to a different memory location. Thus, variables are mutable, but the data they point to is immutable. Huh. How do you, like within scope? What does that mean? Elixir is a garbage collected language. This means you don't have to manually release memory. When a variable goes out of scope, oh, there you go. The corresponding memory is eligible for garbage collection and will be released sometime in the future when the garbage collector cleans up the memory. So you just wouldn't want to make like a big ass, long ass operation, I suppose. But you could. I suppose you could. Being a functional language, Elixir relies heavily on functions due to immutable nature of the data. A typical Elixir program consists of many small functions. You'll witness this in chapters 3 and 4. Blah, blah, blah. A module is a collection of functions, somewhat like a namespace. Every Elixir function must be defined. Oh, man. Pardon me. Inside a module, Elixir comes with a standard library that provides many useful modules. For example, the IO module can be used to complete various IO operations. The puts function from the IO module can be used to print. Okay. IO puts jerk. Okay. As you can see in the example, to call a function of a module, use the syntax module.function name arguments. Fair enough. Def module geometry do. Oh, now we're doing some scope stuff. All right, cool. Boink. Def module. What is the 2? It'll probably tell me. Maybe. Geometry do. Def. What is that? Whoops. Where's my fucking regular browser? Ah, there he is. In Elixir. What do I see? The function's arity, that is the number of arguments the function takes. So string split 2 means the split function in the string module that takes. Oh, cool. What? This notation is important because Elixir allows function overloading based on arity. You can have multiple functions with the same name but different number of arguments. No, but thank you. It makes sense, brother. That's cool. Here. Def rectangle. Oh wait, I do have a question. So if I'm seeing that from I can modify those. Oh, okay. The immediate is a key feature. So, how does the user? Reading the docs. Bitch, alright. Fair enough. A, B, do. I guess it's not terrible. I mean, it's kind of like Pascal. I never wanted to get too deep into it just because I figured it'd get kind of old just writing. I don't know, maybe not. I mean, it's whatever. I shouldn't bitch about it. As long as it's simple. At this point, I just fucking need something simple. There are two ways. Wait. You can find your own. Use def module expression. Oh, so this is a custom one. Okay. You define your own module. Inside the module, you define functions using the def expression. Definition of a module. So I suppose the capital is required. Can't do that. I cannot. Cell compile. Cannot compile cell. Okay. Module geometry 70, 79, 82. What do we do? Rectangle. Oh, a function named rectangle area with arguments a and b. And the logic is multiply a times b and return. Nice. There are two ways you can use this module. First, you can copy and paste this definition directly into IEX. We're not using IEX. We got a lab book, really. Geometry.ex. Using either method yields the same effect. The code is compiled and the resulting module is loaded into the runtime and can be used from the shell session. Let's try it. And maybe I should I don't know if my thingamabob is set up. Left. Whoops. EX. I think it's this one. Cha cha cha. Oh, I never did even make a directory for Elixir. In your config at tool versions. Oops. God damn it, I already forgot what it was. That's zero, I think that was it. Yeah. One dot 1.6.2. Gonna lay off the hashish, brother. Alright. Sweet. Okay. Now we can do it like that. IEX geometry. Oh, but I didn't write it there. Baka. Def module. Geometry. Wait, what happened? Oh, there we go. Geometry do. Def rectang. Pooty tang rectangle. Area. AB do. Do I have to do space? Cool. Ooh, cooler colors in the terminal. All right, now IEX. First, you can copy and paste this directly in IEX. Mention almost anything can be typed into the shell. A second way is to tell IEX to interpret the file while starting. Oh. How do I get out? D? C? A? Did I put... How does it know where it is? It's not in here. Bitch. Callback flush. Directly helpers. This module also includes helpers for debugging. To learn more about IEX. Open the source for the given module or function in your editor. This is fucking cop. I'm just gonna use lab, but it's much better. Okay. Geometry. Yeah, it was pretty simple. All right, so, oh, I didn't do this part. IX. Geometry. Rectangle area. Oh, I like that. That's cool. So I see what they mean now. Okay. Arity, huh? I heard the word, but we never, when I went through the Swift Learnalong, actually, I don't think Swift had that. I don't think you can do that in Swift. I think it had variadic functions, but it didn't show you like that, or they weren't considered different functions. Or what did they call it? Overloading? I want to get that right. That's important. That's pretty cool. How could I use that? Represents the function's arity. Yeah, function overloading. Okay. You can have multiple functions with the same name, but different numbers of arguments. Explain a use case where that would be practical to implement. Meaning, where it would not be more to have a different function. It handles data formatting with optional parameters. Def module money do. What that money do? Def format amount do. Basic formatting with defaults. Format amount currency with separator comma. Or format with amount. Wait. Oh, 1 and 2. So optionals. Format amount. Okay, module, wait a minute. Module money do, and then here's one function with one argument. So function format argument amount do. What? Oh, okay. So this would just only take the amount, and then it's always going to apply USD, comma separated or comma delimited. Full formatting with options. I see. Do. Currency keyword dot get ops. And then the value currency is USD separator. Keyword dot get. What? What is this keyword though? Keyword dot get ops separator. And then the trailing amount. Pipe that format number. Separator. Oh, so these get defined. Weird. What is that keyword? So then here's the amount, and then format whatever is in the amount using the separator, and then add a currency symbol based off currency, and then return it. Cool. It's a little different, but that's neat. Huh. Def P format number separator. Def P. But all part of single module. Huh. What the fuck is def P? Usage, money.format. So just here, aquí. So it just takes the amount, and then we get the USD with separator. Or we can do money.format, currency, euro, separator dot. Ah, man. Neato bandito. I like that. Okay. That makes sense, and it's a good example. Why def P though? Def P format number separator. Def P. Common cases simple, money.format. Complex cases are available when needed, money.format. And default values are dry. Don't repeat yourself. The alternative would be less elegant. Def format simple amount due. Format with options, amount USD, comma. Def format with options. Amount currency separator due. I mean, I guess. Another common example is enum functions like map. Enum map 123 function. I guess that's an anonymous function. Fn. So it takes x and returns x times 2. Okay. What is x? Enum map with index 123 fn x and I return x times I, instead of having to write simple mapping enum.map 123 x. Enum.map normal, enum.map with index. These functions are conceptually doing the same operation like formatting money or mapping over a collection, but with different levels of customization. The operation's core purpose remains the same. It's just parameters that vary. I don't get that one, so I guess I gotta hit the books again. So you may have noticed file name.ex, comment, source code. Geometry, rectangle area. Oh, I didn't even do this part. 6, 7. Cool. Man, I'm hungry. Note, you may have noticed file name is .ex. In the source code, module must be defined in a single file. A single file may contain several module definitions. A module name must follow certain rules. It starts with an uppercase letter and is usually written in camel case style. Camel style. Dots are often used to organize modules hierarchically. close nest module definitions, def module geometry do, def module rectangle do. Do. The inner module can be referenced with geometry.rectangle. Makes sense. Okay. That makes, yeah, a lot of sense. That I like. The other thing, I guess I don't have to use it. It's just ergonomics, so maybe I'll get the hang of it. Or just write a lot more code. For example, consider two libraries, one implementing a JSON encoder and another implementing an XML encoder. Both libraries define the module called encoder. You couldn't use them both in the same project. However, if the modules are called JSON.encoder and XML.encoder, then the name clash is avoided. What about encoder.json? Oh, he just said you can't do that. If the module is called JSON and the name clash is avoided. For this reason, it's customary to add some common prefix to all module names in a project. Usually the application or library name is used for this purpose. That'd be confusing as fuck, but I guess that's not, I mean, it's not different from any other language. Functions. Oh, my chest is so damn sore. As with variables, why is this highlighted? Oh, I guess I highlighted this. Function names can end with the question mark and exclamation. Yeah, I must have. So I'm trying to eat this apple. Guess I can turn on the audio while I do this.
This is typically used to organize the modules in some meaningful hierarchy that is easier to navigate when reading the code. Additionally, this informal scoping can eliminate possible name clashes. For example, consider two libraries, one implementing a JSON encoder and another implementing an XML encoder. If both libraries defined the module called encoder, you couldn't use them both in the same project. However, if the modules are called JSON.encoder and XML.encoder, then the name clash is avoided. For this reason, it's customary to add some common prefix to all module names in a project. Usually, the application or library name is used for this purpose. Section 2.3.2, Functions. A function must always be a part of a module. Function names follow the same conventions as variables. They start with a lowercase letter or underscore character and are followed by a combination of alphanumerics and underscores. As with variables, function names can end with the question mark and exclamation mark characters. The question mark character is often used to indicate a function that returns either true or false. Placing the exclamation mark character at the end of the name indicates a function that may raise a runtime error. Both of these are conventions, rather than rules, but it's best to follow them and respect the community style. Functions can be defined using the def macro.
Do what? Def module.
The definition starts with the def expression and is followed by the function name, argument list, and body enclosed in a do-end block. Because you're dealing with a dynamic language, there are no type specifications for arguments. Note: notice that def module and def aren't referred to as keywords. That's because they're not. Instead, these are examples of Elixir macros. You don't need to worry about how this works yet. It's explained a bit later in this chapter. If it helps, you can think of def and def module as keywords, but be aware this isn't exactly true. If a function has no arguments, you can omit the parentheses.
Def module program do, def run do, def run do. Def run do. What about return value?
What about the return value? Recall that in Elixir, everything that has a return value is an expression. The return value of a function is the return value of its last expression. There's no explicit return in Elixir. Note: given that there's no explicit return, you might wonder how complex functions work. This will be covered in detail in Chapter 3, where you'll learn about branching and conditional logic. The general rule is to keep functions short and simple, which makes it easy to compute the result and return it from the last expression. You saw an example of returning a value in listing 2.1, but let's repeat it here.
Literally the same thing. Why?
You can now verify this. Start the shell again, and then try the rectangle underscore area function.
Yeah. If a function body consists of a single expression, you can use a condensed form. Oh yeah, cool. Def module. Geometry. Do def rec tangle area. AB do A times B. God damn, popping up everything under the sun. Module geometry is already, oh right. So can I just do this? Syntax error do. Ah. Oh, duh, just like that one. I mean, it should work. Yeah. No? Why not? Oh, duh. Geometry. Yeah. I see. Okay. Call a function defined in another module. Use the module name followed by the function name. Yep. So, nah. Geometry dot tangle 7 and or 8 and 3, whatever. 24. Cool, man. It's pretty simple. Pretty fucking simple. Let's see. Of course, you can always store the function result to a variable. Ah, yeah, here we go. You're cooking now. Cooking with gas. Oh, shit. There. Area equal geometry. Booty tang 3 and 2, brother. Why the fuck does it do that? In, motherfucker, in. God damn. Area. Okay. Parentheses are optional in Elixir, so you can omit them. Oh, cool. I like that. Geometry. Rectangle. Oh, that's nice. That's real nice. Fucking in, dude. Personally, I find that omitting parentheses makes the code ambiguous. Oh, do you? Do you? Starting with 1.6, Elixir ships with a code formatter. Oh, neat. Which you can format to get a lot of stuff. Alright. I noticed that. By the way, it manhandled me. Mix format. Go really changed the game with that. If it did anything, it did that. It brought the font. Made it, normalized it as well it should have. It was a good idea. Even though I don't like it. No like it, go. No like it, go. Oh, go you ho. If a function being called resides in the same module, you can omit the module prefix. If the function being called resides in the same module. Okay, that makes sense. Kind of like go package. You can omit the module prefix. Def module do. Yeah. Okay. Yep. Given that Elixir is a functional language, you'll often need to combine functions, passing the result of one function as the argument to the next one. Elixir comes with a built-in operator. The pipe. I was giving my girl some pipe earlier. Called the pipe operator that does exactly this. IEX. Oh, whoa. I should probably do that. -5. Pipes. Abs. Pipes. Integer. To string. Arity 1 or 2. Guess just 1. Pipes. Why do we gotta do the arrow? It's useless. Puts. Harangue. So I'm saying -5. Abs as an absolute value, which would be 5. Passes then to integer to string. So the integer 5 gets converted to string 5, and then IO puts, which gets it to the return. But wouldn't it also just give it back right here? Oh, but as a string. Huh. I mean, why is that? That's odd. It's real odd. This code is transformed at compile time into the following. IO puts integer to string. Okay. More generally, the pipe operator places the result of the previous call as the first argument of the next call, so the following code prev arg1, arg2, pipe next, arg3, arg4. It's translated at compile time to, to closure. Arguably, the pipeline version is more readable because the sequence of execution is read from left to right. The pipe operator. The pipe operator looks especially elegant in source files. You can lay out the pipeline over multiple lines. Wow, brother. Wow. Very impressive. I like it a lot, although I prefer the F-hash way. Multi-line pipeline in the shell. If you paste the previous pipeline chain into an IEX session, you'll notice that each intermediate result is printed to the console. Oh, see. So this puts, it can't output strings. It's interesting. Recall that IEX evaluates the Elixir expression as soon as it is complete and valid. In this example, each line completes a valid Elixir expression, such as -5 or -5 pipe abs, and therefore each intermediate result is printed. Arity describes the number of arguments a function receives. A function is uniquely identified by its containing a module name. And Arity, take a look at the following function. Def module rectangle do. Define area a times b. Or sorry, 2 arguments a and b. Do some logic and then close the scope. The function rectangle.area receives 2 arguments, so it's said to be a function of arity2. In the Elixir world, the function is often called rectangle area /2. Oh, I finally got to it. Okay. I was impatient. He would have got there anyway. Why is this important? Because 2 functions with the same name but different arities are 2 different functions, as the following example demonstrates. Def module rectangle do def area with 1 argument of a, do area a times a, or not a times a, just area, whatever the function of area is. Takes 2 arguments. Or no, that is the logic area. A, def area a. Def area AB, do a times b. How is that first one even an option? What do you mean, comma? Just a. Wait, what the fuck? So, okay, if you pass 1 argument, then you're gonna get breaking my brain here, brother. Define area that takes a, do area a. Define area again, but now 2 arguments, so these are 2 separate versions of it. Define area a and b, you take in a and b, do a times b. What, bitch? Load this module into the shell and try the following. Yeah, that's an interesting looking one. Def module rectang do def area a do area a do areas and then def area again, but different arity a b do a b. Module rectang and then area 2. Booty at booty at booty at booty at booty at do a times b. Oh, but we ain't passed nothing to it yet. Okay. Alright. Now we do rectang area 9 81 because AA. But where, like, where? Hold on a minute. Hold on a minute. That's not what I expected it to do, which is fine, but rectang area a, or whoops, 9 that'd be the same. Am I dumb? Did we already define? Where is the multiplication coming from? What? Or is that in rectangle area? Maybe we defined it already. Rectangle area. Oh, we did. A times B. I guess it's not really. You can't do that. Geometry, but this is def module rectangle, def module rectangle area. Can't just do that, brother. We didn't even fucking. Well, I guess he's about to tell me, but still, that's confusing. If I had go to load this module into the shell, try the following. As you can see, two functions act completely differently. The name might be overloaded, but the arities differ. Okay. So we talk about them as two distinct functions, each with its own implementation. It usually makes no sense for functions with the same name to have completely different implementations. No shit. More commonly, a lower arity function delegates to a higher arity function, providing some default arguments. This is what happens in listing 2.2, where rectangle area 1 delegates to rectangle area 2. Let's look at another example. Def module calculator do def add a. So it takes single argument, do, then add a to 0, and then add, or not and then, but also separate implementation, add a and b, no, define add, takes two arguments, a and b, and then do a plus b. But on the first one, we just say add a, do. That's fucking stupid. Where is that just built in? That must be built in. How the fuck do you get the behavior for add? We didn't even fuck. Bitch ass. Or that's gotta be some. We didn't even fucking define it, brother. How does it know? Or does it flow? Well, it can't, because how would line number 2 know what the fuck? Man, brother. Okay, again, this lower arity function is plenty entitled. This pattern is so frequent that Elixir allows you to specify defaults for arguments by using / operator followed by the argument's default value. What? Oh, so okay, b default value of 0. So lower arity functions implemented in terms of higher arity ones. This pattern is so frequent that Elixir allows you to specify defaults for arguments by using the double / operator. Followed by the argument's default value. Define add a and b, where b's default value is 0. Do a plus b. That's corny. I mean, that should have been shown. Maybe I'll leave a comment. I'm curious if